Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 8 Learning Target 1. Today we are going to talk about simplifying radical expressions. So Unit 8 is all on radical expressions. And we're going to talk about what makes something a radical expression, but first we're going to kick it off with prime factorization. So prime factorization is when you take a whole number and you break it apart into a product of its prime factors. So you're going to break this number down all the way down until it's just written as a product of prime factors. Here's the thing about prime factorization. Every prime number has its own unique prime factorization. No two numbers have the same prime factorization. Every one of them is unique. And then remember, prime numbers are the numbers that can only be divided by 1 in themselves. So for example, the number 3. 3 can only be divided by 3 and 1. So that is a prime number. 7. 7 can only be divided by 7 and 1. That's a prime number. 8, however, 8 can be divided by 2 and 4. That is not a prime number, okay? Because it has other factors besides 1 in itself. So let's just practice writing some numbers out in their prime factorization. So I'm going to start with the number 95. For the number 95, I notice the first thing you want to do is think about what could you divide this into, okay? Divide it into something. I recognize that this number ends in a 5, which means that makes it divisible by 5. So I'm going to take 95 and I'm going to divide it by 5 in my calculator. If you don't have your calculator out yet, now's a great time to grab it. So when I take 95 and divide it by 5, I get 5 times 19. Now I would look at the 5 and the 19 and think, what could 5 and 19 break down into? Well, 5 is only 5 and 1. The only numbers that go into 5 are 5 and 1. And the only numbers that go into 19 are 1 and 19. So 5 and 19 happen to both be prime. Now, when you're writing out a prime factorization, you don't need to write the ones. The ones don't make a difference. So when I write this prime factorization out, I'm just going to say that 95 is the same thing as 5 times 19. That's my prime factorization there. 36, and some of you may only circle this piece right here. Here, let me get a different color. Some of you may only circle the actual prime factorization part. That's fine. You don't need to circle the whole thing, but I just wanted you to recognize that 95 is the same thing as 5 times 19. All right, let's try 36. There are a lot of ways that we can break apart 36. We can break it into 2 times 18. We can break it into 6 times 6. We can break it into 9 times 4. We can break it into 3 times 12. There's a whole lot of factor pairs of 36. Here's the thing. It doesn't matter where you start. You can pick any one of those options and you will get down to the same prime factorization when you go all the way down to the end. So for 36, I'm going to break this into 4 times 9. Okay, 4 times 9 is equal to 36. Now, 4 and 9, neither one of those is prime, which means I need to keep going. So now I have to ask myself, how do I break apart the 4? Well, the 4 is the same thing as 2 times 2. Oops, 2 times 2 there, sorry. And then the 9 is the same thing as 3 times 3. So I have a 2 times 2 and a 3 times 3. Then I would say, can I break apart the 2? Nope, 2 is just 2 and 1. This 2 is also just 2 and 1. Then I have 3, which is 3 and 1, and another 3, which is 3 and 1. So there's no other numbers that can be broken apart right here. So the prime factorization of 36 is 2 times 2 times 3 times 3. Okay. Let's take a look at 72. Now, you may not automatically recognize something that goes into 72, but one thing you should recognize, hopefully, is that it's even. Since it's even, it's always going to be divisible by 2. I also recognize that 72 is the same thing as 8 times 9, so I'm going to do 8 times 9 here. 8 times 9 is the same, or 8 is the same thing as 2 times 4. 9 is the same thing as 3 times 3. Okay, all of these things multiply together to give me 72. I'm not done yet. People get tripped up on 4 sometimes because they think it's prime, but it's actually not. It's a really small number, but it's not prime. So the 2, I'm just going to drag down because I can't break that apart. 4 is going to be 2 times 2. 3 is just itself and 3 is just itself again. So all I do is drag those down. If I need to break apart something else, but there are other things that are done, I just drag them down so that my list at the bottom is my prime factorization list, okay? So all of these numbers, 2 times 2 times 2 times 3 times 3, multiply together to give me 72. And if you typed that into your calculator to check it, you should get that. 2 times 2 times 2 times 3 times 3, 72. So your prime factorization is exactly that. 2 times 2 times 2 times 3 times 3. Now, some people may look at this and write this out in terms of exponents. I may say that that's 2 raised to the third power times 3 to the second power. That's another way that you can write out that prime factorization. Both of them are perfectly fine. And in fact, for our purposes of simplifying radicals, it's probably easier to just leave them expanded. You're going to want to see them all expanded out. So now let's get into a radical expression. So let's start talking about what those things are. It says a radical expression is anything with a radical term. Well, what's a radical term, Miss Johnson, you ask? A radical term is anything that has a square root symbol. That is called the radical sign, okay? That thing right here is the radical symbol, okay? So if you have the square root of 37. That is a radical expression. If you have the square root of x and then plus 4, that's a radical expression. If you have the square root of x plus 4 all underneath the radical, that's a radical expression. Anytime you see this symbol, it's going to be a radical expression. So then let's talk about how we would simplify them. So if we want to simplify radical expressions, which is something we're going to do often, we need to make sure that there are no perfect squares left under the radical, there are no fractions under the radical, and there's no radicals in the denominator of a fraction. Okay, so the one that we're going to focus on today is this first one. How do we get rid of the perfect squares that are underneath the radical? All right, so let's talk about simplifying the expression. So if I take a look at this, I've got the square root of 50. Now, we need to look for any perfect squares under the radical. And the way we look for perfect squares under the radical is to do the prime factorization and then look for any factor pairs, because factor pairs are where we get the perfect squares. So I'm going to break apart 50. Anytime I have something that ends in 0, I like breaking it apart into 10. And whatever it may be. So 50 is the same thing as 5 times 10. Now the 5 is just 5, so I'm just going to drag that one down. But 10 is the same thing as 5 times 2. Okay, so here's my prime factorization of 50. That's what I have here. Now, I want you to rewrite that under your radical and see what I'm looking, and then I'm going to talk about what we're looking for. So if I write that under my radical, I've got the square root of 5 times 5 times 2. Okay, what gives me a perfect square are any sort of factor pairs. So by factor pairs, what I mean is that you're going to look for things that have a pair with themselves. So like this 5 times 5, this is a factor pair right here, okay? 5 times 5 is 25. 25 is a perfect square. So this factor pair, this one factor pair underneath the radical comes out front of the radical and makes a 5 outside. So if you think about it, the square root of 25 is equal to 5. So what I'm doing there is I'm breaking down the square root of 25 and I'm bringing the 5 out front outside of the radical. But now here's the thing. You still have this square root of 2 left over. So you have to write the square root of 2 behind. So the way we say that is 5 root 2. Okay, the square root of 50 simplified is 5 root 2. So that one factor pair of 5s came out front to make a factor of 5 outside. All right, let's take a look at the 48. So in 48, I can break this down however I want. I'm going to break it down into 4 times 12. 4 times 12 there is 48. The 4 would then be a 2 and a 2. The 12 would be a 2 and a 6. This 2 is done. I'm just going to drag it down. This 2 is done. I'm going to drag it down. That 2 is done. The 6 is a 2 times 3. So There's my prime factorization list. 2, 2, 2, 2, and 3. Those are all prime numbers. So now imagine this whole list being underneath a radical. Okay, so if that whole list is underneath the radical, what factor pairs can be circled and brought outside? Here you have a 2 times 2. It can be brought outside to be 1 factor of 2 outside. Here's another 2 times 2. That can be brought outside to be another factor of 2 outside. The 3 is by itself. It doesn't have a pair. So the 3 has to stay alone. So then I'm going to leave that underneath. Now on the outside, I have that 2 times 2. That I can put back together. So that gives me 4 square root of 3. So the simplified expression for the square root of 48 is 4 root 3. All right, let's take a look at 32. So in 32, or number 3, I should say, with the square root of 32, I can break that down into 4 times 8. So let's do 4 times 8 there. So I've got 4 times 8. 4 is 2 times 2. 8 is 2 times 4. And then I can break down that 4. So the 2 comes down, 2 comes down, I'm done. 2 comes down, I'm done. 4 is 2 times 2. So I'm looking at 1, 2, 3, 4, 5 factors of 2 there. So again, imagine these all being under a radical, because that's what you did. You broke apart the 32 that was underneath a radical. So if these are under a radical, what are my pairs? I've got this pair of 2's that can come out front. I've got this pair of 2's that can come out front. And then I've got this 1, 2 left over behind. Then I have 2 times 2, which is 4, times the square root of 2. 4 root 2. That's my simplified expression. So what I've done here is I've made sure that there are no perfect squares left underneath the radical. All right, let's try it again. Square root of 125. So for 125, it ends in a 5, so I'm going to divide it by 5 and start there. 125 divided by 5 is 25. So I've got 25 times 5. The 25 is the same thing as 5 times 5. And then that 5 is going to drag down. 5s cannot break into anything else. So if I imagine these underneath a radical, I've got 1 pair of 5s right here that can come out front. And then times the square root of 5. So left over behind. So my simplified expression is 5 root 5. Okay, let's take a look at the square root of 80 in number 5. So in number 5, I've got the square root of 80. I'm going to start by breaking that into 8 times 10. Again, anytime something ends in a 0, I like breaking it into the 10 just because that's an obvious thing to break it apart into. You don't have to. I could have done 5 times 16 or anything else. But breaking it apart into 10 is an easy one. All right, so 8 is the same thing as 2 times 4. 10 is the same thing as 2 times 5. Then I can break apart that 4. So 2 comes down. 4 is just 2 and 2. This 2 comes down. That 5 comes down. So I end up with 2, 2, 2, 2, and 5. If these were under a radical, what pairs could I take out? I could take out this pair of 2's. I could take out this pair of 2's. And then the 5 doesn't have a pair, so it's going to stay underneath. Then I look at 2 times 2, which is 4, times the square root of 5. And again, you can check these on your calculator. If you type in the square root of 80 on your calculator and see what decimal you get, the square root of 80 is going to be 8.9. 8.944, and it keeps going on. And then type in 4 times the square root of 5. 4 times the square root of 5. You better get the same decimal answer. Okay, so these two things better equate to each other because the square root of 80 simplified should equal whatever you got for your simplified expression. All right, let's take a look at number 6. I've got the square root of 45. So I'm going to break 45 into 5 times 9. And then 5 cannot be broken down anymore, so that's just a 5. And 9 is 3 times 3. 5, 3, and 3 are all prime. You can't do anything else with them. So that's what's under the radical. That's the prime factorization of 45 there. The pair that I have is a pair of 3's. So I bring my pair of 3's out front, and I end up with the square root of 5 behind. No other multiplying to put together, so that's that. Let's try number 7, square root of 100. Now, I want to talk about this one specifically because we all should know, hopefully, that the square root of 100 is equal to 10, okay? We know that 10 times 10 gives us 100, but I want to show you what it looks like if you break it apart into the prime factorization. So we know we're going to get 10, but let's just see if we didn't recognize that, or if something comes up and you don't recognize that it's a perfect square, because 100 is a perfect square. If you don't recognize that you've got a perfect square, here's what would happen. I'd end up with this one being, let's say, 50 times 2. Because that also gives me 100. Let's say I put 25 times 2 and then bring this 2 down. Let's say I make this 5 times 5. I bring a 2 down and bring a 2 down. Take a look at what I have under my radical. I've got a 5 and a 5 and a 2 and a 2. That's a pair of 5s out front and a pair of 2s out front. So I have a pair of 5 and a pair of 2. That makes 1 factor of 5, 1 factor of 2, and you've taken care of everything under the radical. There's nothing left under the radical. And what is 5 times 2, you ask? 5 times 2 happens to be 10. So if you didn't recognize something was a perfect square, it is possible that you'll end up with no radical part left over. Okay, it's possible to see that or acquire that. Okay, let's talk about number 8. Now we've got this pesky little 2 out front. Okay, how does that change things? All right, so the only part that you want to break down is the 75. That's the only piece that's underneath the radical. So break down the 75. I'm going to break this into 25 times 3. Think quarters. Whenever I see things like that, I break them apart into quarters. So 75 cents is 3 quarters. That's 25 times 3. 25 is the same thing as 5 times 5. And then this 3 also still comes down. Okay. Now, that's what's underneath my radical, but this 2 was already out front. So we can't forget about the 2 that was already out front. It's still there. We didn't do anything with it. Now I also need to think about bringing the pairs out. So I've got a pair of 5s that comes out front to be a 5 with that 2 that was already there. The 3 has to stay. I can't do anything with the 3. So the 3 is going to stay underneath the radical. Now I'm going to put the 5 that I brought out with the 2 that was already there and make that 10. And I get 10 root 3. And again, if you type that into your calculator, it better equal that. Okay, so that's the simplified expression because there's no perfect squares left under the radical. Okay, one more time. Let's look at 96. 96 is the same thing as... I'm dividing it by 2 here. 48. 2 times 48. And then this 2 is going to come down. 48 breaks into a lot of different things. I'm going to do 6 times 8. Doesn't really matter. Like I said, you can start anywhere. You'll end up with the same end result. One more row. A lot of factors in 48. This 4 is 2 times 2. Okay, so now let's take a look at what pairs we have. So if this is my prime factorization of 96, I've got a pair of 2s. So 2 out front. This 3 is by itself. I have a pair of 2s right here. So that's another factor of 2 out front. This 2 does not have a pair. And 3 and 2 are not the same thing, so they're not a pair. So they're both going to stay underneath. Okay. Now when I put this all back together, 2 times 2 gives me 4, and 3 times 2 gives me 6. So I have 4 root 6 there. So again, think about typing those into your calculator. If you type in the square root of 96, you better get the same numerical result as 4 times the square root of 6. Okay, we're going to practice a couple more here, and then we'll be all done for today. So let's talk about number 10. We've got 4 times the square root of 64. Now, again, if you don't recognize that this is a perfect square, you can go through the prime factorization and get to the end that way. I recognize that the square root of 64 is just 8. So this whole thing just ends up being 4 times 8. 4 times 8 is 32. That's what I get there. But the square root of 64, that's the same thing as 8 times 8, which is a pair of 8s that would come out front and be 4 times 8. All right, let's talk about 384. This is a big number, 384, and then I'm multiplying it by 3 on the outside. Okay, so 384 is this large number here that can be broken down into, I'm guessing, a whole lot of things. Now, it's even, so you could start by just dividing it by 2. But I also recognize that it ends in a 4, so I'm going to try dividing it by 4 and see if I can get it into something that way. When I divide 384 by 4, I get 4 and 96. Okay, so that helps me a little bit more than the 2, because the 2 is going to leave me with a whole lot of factors that I have to break down. But 96 still has quite a few. And then also don't forget that we have this 3 that we're going to have to include at the end. So let's keep going with our prime factorization here. I've got 4 being 2 times 2. I've got 96 being, we did this one already, I think, 2 times 48. Or 96 divided by 4, 4 times 24. How about that? 4 times 24. 2 comes down, 2 comes down. 4 is 2 and 2. 24 is 4 and 6. 2, 2, 2, 2. 4 is 2 and 2. 6 is 2 and 3. Look at all those 2's. There's a lot of 2's there. That is the prime factorization of 384. You've got 2 times 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 3. So look for the pairs. Here's a pair. Well, and then don't forget, 3 was already out front. So I've got a 3 out front. I'm going to bring a 2 out with it. I'm going to bring another 2 out with it. I'm going to bring another 2 out with it. And then I have a 2 and a 3 left over. 2 and 3 are not a pair. They're 2 different numbers, so you cannot bring them out together. So they have to stay underneath. So now let's put that all back together. I'm going to use my calculator to help me. So 3 times 2 times 2 times 2 is the same thing as 24. So 24 times the square root of 6 is what I have there. And again, you could type 3 times the square root of 384 into your calculator, and then also type in 24 times the square root of 6, and you should get the same answer. All right, last one that we're going to look at together today. So 216, I see that it's even. I wonder if it's divisible by 16. It's not. That didn't help. How about 8? Ooh, it's divisible by 8, so that's good. So 216, I realized that it's divisible by 8, so that I break this apart into 8 times 27. 8 is the same thing as 2 times 4. 27 is the same thing as 3 times 9. Then I've got this 2 comes down. 4 is 2 and 2. 3 and 9 is 3 and 3. All right, so that's my prime factorization. That's what's under the radical. These are all being multiplied together. What are my pairs? This pair of 2's can come out. This pair of 3's can come out. I've got a 2 and a 3 left over that have to stay underneath. So this ends up being 6 times the square root of 6. All right, that takes us to the end of our first notes into Unit 8 today, talking about simplifying radical expressions. Thanks for tuning in, and I'll catch you next time.